This is the Electricity Homework Booklet, question 8. You are shown the characteristic graph for a filament lamp. When you're given these graphs, always begin by checking the axes to make sure you are interpreting them correctly. In this question, you are basically asked to explain the shape of the graph and the significance that this has. So you're asked to explain why, as the voltage is increased, either positively or negatively from 0, the characteristic has this shape. Now I've colour-coded the graph, and the comments below match the particular sections that have been highlighted. Notice there are 7 statements in total, but only 5 marks have been allocated to this question. So any 5 of these 7 statements would lead to a full mark answer. So first of all, we look at the central section of the graph. A small part of the graph is showing as a straight line. So this means that Ohm's law is obeyed. Considering why that is the case, there is a small current in the filament wire, and it will heat the filament, but to a steady temperature. That means if the temperature is constant, so the resistance will also be constant, and that is why we have a straight line graph through the origin. Next, we consider what happens at larger voltage values. So if we increase the voltage further, that also leads to an increase in current. But the increase in current also leads to an increase in temperature. So now overall, the temperature is no longer constant as we move up the graph. So if there's an increase in temperature, we also have an increase in resistance. Because the resistance increases as we move along this line, that means the rate of increase of current is less than it would be if the resistance had remained the same. So if the resistance had remained the same, we'd expect the graph to carry on in a straight line, but in fact the current increases less than previously for a given increase in current. Finally, the question did refer to increasing the voltage either positively or negatively. So you can comment and say that if a negative voltage was applied, exactly the same effect would be observed. Finally, a calculation. So at a certain point on the characteristic, you are told that the power developed in the lamp is 20 watts and the current is 90 milliamps. You're asked to find the resistance of the filament lamp at this point. You may go directly to this equation, linking power, current and resistance. Just remember this comes from the equation P equals V times I, and substituting in, replacing V with IR. So rearranging this equation, you get an expression for the resistance, and you simply divide the power by the current. Be careful with the units though, we have milliamps here, so you need to multiply by 10 to the minus 3. Finally, leave your answer to 2 significant figures and include the units.